Good morning, students. So, this is chapter 3 for 12th standard, which is magnetism and magnetic effect of current. In that, in the last video, you have learnt about torque. Torque, where it is kept in a permanent magnetic field, you take a bar magnet. So, the topic enhances like to find out potential energy of a bar magnet in a uniform magnetic field. So this is what the uniform magnetic field is. Again, this SN is what the bar magnet which is kept, and in the bar magnet, only from the pole strength you will find out what is the length of the magnet. So this is what the perpendicular you drop at both north and south pole, that will be 2L sin theta. All the consideration is the same. So you know that this dipole will have a dipole moment of Pn. It is understood. And torque, what is the answer of torque? We have found is that tau b will be equal to Pm into b sin theta. And this dipole is rotated through an d theta value. That is, it is going to have a, like, when will you have a torque is when it is going to have a displacement, or there is a force which is exerted, which makes the magnet to move. So naturally or definitely it will have an angular displacement of d theta. So always what is work done? Work done is always force into displacement. Right from your 10th standard you have studied, always work done is equal to force into displacement. It will vary according to its consideration, that's all. Otherwise this work done, it is what is stored as potential energy. The concept is the same, but it varies according to the problem that we are going to consider. So here again, force into displacement. Force is in torque, moment of force, and displacement is d theta. So tau b is equal to tau of external. Nothing. See, this is the external field. That's all. Otherwise, it's the same. So they both are the same. So now I need to find out what is dW. That is the small work done, which is with respect to d theta. So PMB sin theta into d theta. How will you find out the total work done? Nothing. It is just simple. You need to integrate it. Integrate from d phi 1 to phi. Tau into d theta. Substitute the value. Then these both are constants. P, M and B are constants. You are going to integrate only sin theta. By integrating sin theta, you get minus cos theta. So applying the limits, upper limit minus lower limit. So it is cos theta minus cos theta dash. Then, so you write it like this, minus PMB cos theta minus cos theta dash, where if theta is going to be 90, if theta is going to be 90, then what happens? Cos 90 turns to be where this 1 will get 0 and this minus sign will get eliminated. So this turns to be minus PMB cos theta. This happens only when theta is equal to 90 degrees. So if theta is equal to 90 degrees, you got an answer. That is what is potential energy U. That is amount of work done is stored as potential energy. So U is equal to, it consists of maximum at theta is equal to 0 or 180. So minus Pm into B, because cos theta here, cos 0 is 1, cos 90 is 0. That is why. So this is what you get it as U value. Now you consider theta to be 0 degrees, then cos theta, in the place of theta you will get cos 0, so 1, so you get minus. negative maximum, but it is having an maximum value there. Then theta is equal to 180, so cos 180 is minus into minus will become plus, so positive maximum. So what do you infer from here is that potential energy of a bar magnet is minimum when it is aligned along the external magnetic field, and minimum when the bar magnet is aligned anti-parallel to the external magnetic field. This is what the inference that you conclude from the potential energy.